All right, well, this is Charity McKenzie with IDEA, and this video is going to be on multi-step equations. So, oops, it did not let me do this. So multi-step equations, So this kind of takes everything from 1 steps and 2 steps and kind of starts mixing it all up, and it mixes in the use of parentheses and the distributive property and being able to add like terms. Remember, like terms have the same letters with the exact same exponents. So that's kind of what multi-step is going to include, is a lot of things. And if some of you are in the lower level math classes, like maybe 7th, 8th, or pre-algebra, this topic, the problems will be a little more basic, whereas when you get into algebra and algebra 2, this is going to be a lot harder equations. So basically they get harder and harder, but you still do the same process. All right, so let's look at, let's do ones, multi-step. Okay, let's do ones to start with that have a parenthesis in them. So we're going to maybe have fractional answers, but here's my first example. What if I have 2x minus 4x plus 3 or equals, I don't know, 7 minus 11. Okay, so what if I had something like this, looking kind of ugly? We got our equal sign right here in the middle, and we have quite a bit to this problem. So what we start with, when I said we were going to start with one of the parentheses, and I didn't write it, but that's okay. So what we're going to start with is we simplify the left side and the right side by themselves, whether they have a parenthesis or not, which we'll have some with that as well. But you simplify the both sides, and then you start doing opposite operations. So when I look at this left side, do I have any like terms? Okay, well, if I look, the 2x and the minus 4x both have just an x, so we can add those two terms together. So 2x minus 4x would give you negative 2x. So you add or subtract the front numbers and keep the letter. So those combined would give us negative 2x, and then we still have the plus 3 equals 7 minus 11. Okay, so if I look to the left side, can I combine anything else? Well, I can't add an x and a number, so I'm actually as simplified as I can. So then let's look at the right side. If you look at there, I have 7 minus 11, so I can simplify the right side some more. Okay, so the left side is going to stay the same as negative 2x plus 3, and then 7 minus 11 would give us negative 4. All right, I almost put negative 3. Okay, then from here, I am now have both sides as simplified as I can. So I find the letter, and there's only one letter here over on the left side now. And I'm going to do the opposite operations till that's by itself. So I'm going to start with the number next to it. And I see add 3, so I'm going to do the opposite, which would be to minus the 3 from both sides. And these two would cancel, and I have negative 2x equals negative 4 minus 3 more is negative 7. And then I'm going to divide by negative 2 because I see multiplication, so I'm going to divide, and those would cancel, so I have x left. 7, negative 7 divided by negative 2. Well, you can't actually divide 7 by 2. Because it's odd and it doesn't go in evenly. But a negative over a negative does equal a positive. So I can reduce it to a positive 7 halves, but I'd leave it 7 halves. Sometimes if it asks your answer to be in a mixed fraction form, you can change it to a mixed fraction. And you do that by seeing how many times 2 goes into 7. So this could also equal, well, 2 goes into 7 3 times. And that's going to give you the number 6. And to get from 6 to 7, you'd have 1 left out of the 2, or 1 half. So 7 halves is the same as 3 and 1 half. All right. And again, the 7 halves is fine on most of your questions, but you can have that additional step. Okay, so let me take one from, let me do this one here. I like this one. So what if I have 17 equals 3? Then I have, and I'm going to change my letter to a P minus 5. plus 8. Okay, so here's a multi-step problem. And it has a parenthesis on the right side. So the left side can't be simplified, so it's going to stay 17. But let's simplify the right side. So if I look, I have a 3 in front of the parentheses. So what I can do is actually multiply this through. Remember, this is called the distributive property. So 3 times p would give you 3p. 3 times 5, bring down the minus sign, is going to give you 15. So I got rid of those parentheses, but I still have my plus 8 over here. Okay, so I got rid of the parentheses. Now I can simplify any like terms. The negative 15 and the 8, both are just numbers, so I can simplify those together. But they don't have a p, so they can't be combined with this one. So I would have 3p, negative 15 plus 8. You have more of the 15, so it's going to be negative. And that's going to be 7 when you subtract the 8 and the 15. All right, then from here, here's the p. So I got to get rid of the 7 first by adding it because I see a minus. So I'm going to add 7 to both sides. They cancel here. 17 plus 7 is going to give you, what? 7 and 7 make 14. This is confusing me. I keep thinking that's 17 plus 17, but 7 and 7 make 14, and then you have 24. Okay, so 17 and 7 make 24. And then we still have 3p on this side. Okay, and then to get rid of the 3, it's times, so I'm going to divide both sides by the 3, and they cancel here, which is great, so I have p equals 24 divided by 3 happens to be 8. And I forgot to show you the check on the first one. So the checks probably is a great way to put into your scientific calculator. So you would put the 8 here for p, and you'd go 8 minus 5 is 3. 3 times 3 is 9. 9 plus 8 is 17. Okay, on this side it'd be a little harder because it's 3.5. 3.5 doubled minus 4 times 3.5. Anyway, so you can calculate that one out to see if it works out to be negative 4 on the left side. Okay, so there's another multi-step. I was trying to think if I wanted to do fractions in a separate one. I think I do. All right, so the rest of them have fractions in them in most of the problems that make them a little bit more challenging, or maybe a decimal, but most people just don't struggle with decimals as much as they do fractions. So for multi-step, this is about as advanced as we want to go. So I'll do a separate video for variables on both sides and a couple more complicated ones. So simplify both sides and then go from there. So this is my multi-step equations.